Before you can use vectors, you need to be able to do things with them. And really, there are only two fundamental operations. You can add two vectors together, and you can multiply a vector by a scalar. That is it. Those two operations, in various combinations, produce every gradient update, every attention weight, every residual connection in deep learning. Today we get them completely solid, both algebraically and geometrically. Vector addition is beautifully simple. Add corresponding components. If A equals 3, 1, and B equals 2, 3, then A plus B equals 5, 4. That is the algebra. The geometry is the tip-to-tail rule. Place the tail of B at the tip of A, and the resultant goes from the very start to the very end. Draw this on paper now. In 2D you can see it clearly. The two vectors form two sides of a parallelogram and the resultant is the diagonal. Once you see it, you own the intuition forever. Scalar multiplication is equally elegant. Multiply a vector by a scalar and you scale its length without changing direction. Multiply by 2 and the vector doubles. Multiply by 0.5 and it halves. Multiply by -1 and it flips to point the opposite way. In AI, the learning rate is a scalar and the gradient is a vector. When you write W minus learning rate times gradient, that is scalar multiplication followed by vector subtraction. That single operation trains every neural network in existence. In NumPy these operations are natural. Vector addition is A plus B. Scalar multiplication is K times versus, and the most important operation you will use is the linear combination. Multiply each vector by a scalar and add them all. Linear combinations are the core of matrix multiplication, attention, and virtually every transformation in deep learning. Open Jupyter now. Create two vectors, compute their sum, difference, and scaled versions. Then compute a linear combination. Build the muscle memory today. 4 places in AI where these are the literal mechanism. 1. Gradient descent. The weight update is new weights equals old weights plus a negatively scaled gradient. Scalar mult then add. 2. Transform attention. Output is the weighted sum of value vectors. Attention weights are scalars, values are vectors. Output is scalar mult plus add, repeated for every head. 3. ResNet residual connections. Output equals f of x plus x. One vector addition that solved vanishing gradients in 2015. 4. Anomaly detection. Subtract baseline state from current state, measure the norm of the delta. Key takeaway: vector operations are the grammar. Everything else is a sentence. Addition combines directions. Scalar multiplication stretches or shrinks. Together they form the linear combination, the single most important operation in all of machine learning. Before video 6, do the exercise, create two vectors in NumPy, compute their sum, difference, and scaled versions, verify by hand, then draw the tip to tail on paper. Both take under 10 minutes and will make the dot product in video 6 land immediately. If the geometry of vector addition clicked for you today, if you can picture what happens when you add two arrows in space, hit the like button. Subscribe so video 6 is waiting for you. The dot product is next, the operation that lets AI measure the angle between any two vectors, and why that angle equals similarity between words, images, users and products. Share this video if you know someone who keeps saying they will get to linear algebra. See you in video 6.